Okay, go ahead.
Our idea for project is from bow.
Oh, yeah.
Yes.
Bow and arrow.
And our projectile really can hurt people.
Yes, try to be nice, please.
So the materials that we use are cardboards, rubber bands, and pencil, and also gallery caps. So the reason that we choose this for our projectile is because it's light and it's recyclable, and it's also really small, so it can fly really far. And we also cut a little square on the edges of our cap so that it can fit the rubber band thing. Yeah.
Also, we have 4 different degrees, and we use a pencil to.
Sure.
Yes, this is 6 degree, 45 degree, 30 degree, and this is 90 degree. Yeah.
How did you measure that angle to make sure it is?
Yeah, we use
Angle measure.
Go try to angle measure.
Yes.
Okay, good.
So this is how we launch it, like this.
Can you do like a sample for us? Here,
Yeah.
Jesse, go stand in front of that. Okay, go ahead. Give me your best shot. I'm not even moving. Let's see if you can hit me.
Yeah.
Yeah.
Okay, that's how it works.
Yeah.
Got it. Oh, that's kind of neat. Cool.
Okay. The result from our experiment is that our projectile can reach the furthest point when our launcher is 30 degrees, because our projectile is a buttercup. It has a flat shape, so its surface area is bigger. It's flat, and in normal situation, 45 degree is the point that the projectile can reaches the farthest point, but ours doesn't.
Why?
And
Because
yeah,
it has a flat
different
shape.
projectile.
And its sourced area is big. It's not like a rock. It has a big mass. It's very light, and it's flat.
And we also figure out that if our launching angles are bigger, the heights will increase, and also they have a shorter horizontal distance. And our changing variables is the weather. So we launch it indoors first, and then we also launch it outdoors, so it's kind of windy. But that day was a nice weather, so the result didn't affect a lot. Yeah.
Yes.
So that's.
And I will show a video.
Can you show it there? Yeah, that's it. Anyways, actually, yeah, that's it. Our video.
No video?
So take your time.
Start firing projectiles back at him, man.
Yeah, just.
That's what the audience does. It's not working? the video?
Oh, I found it. Yeah.
You got
It's
it?
working. Yeah.
Okay, let's see.
Wait.
Alright, here we go. You gonna have some Lady Gaga too?
No, we don't have
No
music.
Gaga? No music?
Yeah, no music at all.
Oh, come on. Wow, good celebration. Were the results the same, outside, inside?
Yeah, because it's not really deep, so
Yes.
we thought it.
Did you try different projectiles besides that one?
We try to use paper, like we wrap it in paper, and we also try to use a lot, like eraser.
Different things.
But this
This worked the best?
Yeah.
Easiest to shoot.
That shot the best?
Yes.
You think it's because of its shape? It looks like a puck or a
Yeah.
saucer?
Yes.
Does something like this work? You shot it?
I don't
But
know.
it'll hurt people, so.
Well, you're not shooting it at people, but
There are people inside.
yeah, and that wasn't the goal.
Yeah, I think it's working. I think
Yeah, I
it should
think it
work.
worked.
Because I think that'd be an interesting follow-up to find out what shape projectile would travel the longest distance. And I think if you look at ancient man, you look at maybe how ancient warriors used to fight, you'd find your answers. What do you think the answer would be? When human beings shoot things into space, what's usually the shape of it?
Sharp.
I don't know.
Arrow
Pointed with cylinders. Cylinders that are pointed versus saucer. You want to think maybe why is a cylinder like this? Rockets are shaped like this. Okay, they're not shaped like they're not shaped like this. What do you think the reason is that rockets or arrows all share the same shape? Why?
Because they fly further, like furthest.
But why?
They're the same.
Like the.
Well, air is part of the reason, but why? Why would this fly better than this? If I were to be an engineer and I'm going to launch something, what is the physics behind why if I put the same force underneath these?
Its surface area is small.
Surface area is smaller, so you have less what?
Less
Less
force.
resistance. Absolutely. And that's all aerodynamics. So when you launch things, you want to try to have the least amount of resistance therefore you can maximize your force and get greater bang for your buck. This would be very hard to shoot, and this would be much easier to shoot because it slices through the air. The good thing to look at is look at how airplanes are designed. Airplanes, they look like, or even animals. Like what animal? Think of water, for example. What animal is one of the fastest in the water?
Shark.
Shark. What's a shark look like? An airplane. What does an airplane look like? A rocket. Because they're all going through mediums, and they share a certain geometrical shape. A whale is not slow because a whale looks like this, right? So it's interesting to look at how nature and how man has used some of the natural things to shape their inventions. Okay, very good. Thank you. Gotta be the Jesse Show now. The Jesse Show.